Hello, everybody, and welcome to our webinar, Sensors and COVID-19, Problems and Opportunities. Before starting, let me briefly introduce myself. I'm Giovanni Principe, Product Manager for Ultrasonic and Capacitive Sensors here in MD Microdetectors, and today I'm gonna lead you during this lecture. I'm not alone here because there is a colleague of mine who is going to support me.
Hello, Giovanni.
He is Giovanni Di Lorenzo, our product manager for inductive and applicative sensors and accessories. He's going to collect your questions and trying to answer them. So please, if you have any doubts or curiosities or something is not so clear, do not hesitate to write us down in our chat, addressing your questions in the to the Q&A profile, and Giovanni will be very happy to answer you. Okay, I think now we are ready to start. First of all, why did we decide to provide you this special webinar, this special lecture? Because as all of us know, unfortunately, the COVID-19 has gotten an important role in our everyday life during the last months. Because unfortunately a lot of people all around the world got infected, a lot of people died, and let's say lots of our everyday life habits dramatically changed. But on the other side, a lot of new business opportunities in terms of new technological applications emerged. In fact, this new, let's say, unforecastable situation need to be managed in some way. So it is necessary to adopt new technological solutions. In particular, we are going to discuss about these points. First of all, we are going to discover which are these new necessities related to the diffusion of the virus itself, new necessities to be satisfied. Then, how they can be translated in terms of applications. And third, how we can answer, how we can provide the right answer through our wide product portfolio. Before starting, let's have a look on this tragic picture where it is possible to observe the global diffusion of the SARS-CoV-2 virus. In fact, about 188 countries in the world, over a total number of 196 countries, have been affected by the diffusion of this terrible virus. And if you have a look on this number here, which is the number of the infected people all around the world, we can observe that just today we have overcome the 13,500,000 people infected. On the other side, unfortunately, more than 500,000 people have died. Furthermore, a lot of everyday life habits dramatically changed. In fact, we can think about the long lockdown, even in Italy, but also other European countries or other countries all around the world, where the lockdown lasts months. Okay, and we can consider also the difficulties in traveling among different regions, among different countries. and the limited accesses to open to public places in order to grant the right social distance. But the other phase of the medal, as I said before, is represented by these new technological applications needed to better manage this dramatic situation. And MD microdetectors, thanks to its wide product range, can answer in the right way. In particular, we can offer photoelectric sensors, ultrasonic sensors, capacitive area sensors, and safety devices. And now we can go deeper in detail in exploring, in discovering which are the practical applications that we already solved and that we are going to solve during this period with our products. And in order to share with you our know-how, our expertise, we can start from these guidelines, which are the recommendations and the restrictions imposed by the World Health Organization. First of all, we know that it is important to have a continuous temperature control, a continuous body temperature control, because the body temperature is an important index of our health, because if the infection has started in our body, the first indicator is represented by the high body temperature. The second point is represented by the cleaning of our hands. It's important to grant this hygienic level, because the hands are the most significant mean of transmission of the virus through then the nose, the mouth, and the eyes, by touching them, of course. Third, keeping the right distance and avoiding the overcrowded places. Fourth, cleaning the surfaces through an effective sanitization. And for the same reason, because the virus is unfortunately able to survive on top of surfaces for hours and days, it is recommended to not touch continuously the handles, so to prefer some automatic solutions in opening the doors. And then, of course, the usage of the face mask. In fact, the face mask acts like a filter during our inhale and exhale phases. So let's start with the civil applications, with some of the most significant civil applications that we have solved. Let's start with the measurement of the body temperature. This activity can be performed thanks to an automatized thermoscanner. This is a tool installed within a totem in the external part of a public space, let's say a restaurant, a bar, a theater, a cinema, and so on and so forth, where we are going to measure the temperature of a potential new entrant, a potential user who is going to enter this public space. The necessity here is represented by the detection of the presence of the user just in front of the thermoscanner, because in this way we can activate the thermoscanner itself when the user is there, and deactivate it when the user goes away. For this application, we suggested and we, let's say, we provided an ultrasonic solution. We can suggest both UK series and UQ1. But why ultrasonic solution? Why ultrasonic technology? Because this technology is independent from the color of the target surface. It means that the user can have no matter of clothes in terms of colors, and the sensor is able at the same way to detect the presence of the person. Another important point is represented by the immunity of this sensor to the sunlight, to the external light, which can become an interference, for instance, for a traditional photoelectric sensor. Then here you can read the effective background suppression. What does it mean? It means that with an ultrasonic sensor, we are able to set a specific distance in a precise, very precise and accurate way where we want to detect the presence of a user. It means that we are able to, let's say, to not consider the passage of the random passage of people behind the target user. So we avoid to have false alarms. And another point is that the user can stay also, let's say, at 1 meter, 1.5 meters of distance from this totem. At last but not least, the ultrasonic technology is able to work externally because the solution is effective also with the presence of fog or dust. Let's move now to the second application. In other words, the hygienic dispensers. These dispensers have got a wide diffusion in companies and public spaces, and they are installed overall at the entrance points where you should, let's say, disinfect your hands. And also here in MD Micro Detectors, we have installed, let's say, more than 6 of these hygienic dispensers in the most significant points where there is the flow of people. And the necessity here is to detect the presence below of the dispenser itself of the hands. And we have installed for this particular application, we have installed some photoelectric sensors of FA or QM series. Why photoelectric sensors? Because with these models, we have the possibility of working with background suppression models. With the background suppression models, a sensor is able to catch at the same distance a target, no matter of the color of the surface. In fact, especially during this period, we usually wear gloves, and gloves we know can have different colors. They can be dark, they can be lighter. A sensor should be able to detect the hands no matter of these, let's say, particularities. Another point to be underlined about these photoelectric sensors is the presence of, let's say, M18 models with 90 degrees emission. This is a crucial point because in this way we can install these sensors in limited spaces, and we can, of course, let's say, have a lot of savings as consequence. Another important point, another important application is referred to the management of the overcrowded places. In fact, in order to grant the right social distance, we have to avoid these overcrowded places. But first of all, we have to monitor the inflow and the outflow with respect to these public spaces. How to do that? Even also in this case, we can use photoelectric sensors of FA and QM series. But in order to understand how many people are in a specific place, for instance, in a supermarket, we have to distinguish between the inflow and the outflow in order to rightly count how many people enter and how many people go outside. In this way, in this case, we just installed a couple of photoelectric sensors, as you can observe in this picture, and we are able to distinguish between the in and the outflow just on the basis of the order of the sequence of beams that are interrupted through the passage of a person entering or coming out. I want here to underline an important point about our models. We have the possibility of providing models with infrared emission. Why it is so important to, let's say, have infrared emission instead of red one? Because with the red emission, we have the so-called viewfinder effect. And the viewfinder effect can create some, let's say, some disturbances in person who see these red spots on their clothes. The narrow beam emission of these photoelectric sensors allow us to install them in very limited space, one beside to the other. We can move now to the other application, which is related to the sanitization of surfaces, and in this case, sanitization of food. Imagine in a supermarket or a restaurant where there is the distribution of food thanks to these counters, thanks to these refrigerators. It is important, due to the frequent touch of users, of persons coming here, to have a total disinfection of these surfaces. And how to do it contactless? We can do it with ultraviolet lights. In fact, as a recent research performed by the University of Modena, with a published just yesterday, let's say, we know that the virus can be destroyed, can be killed in some seconds by using this mean, by using the ultraviolet lights. Obviously, when using ultraviolet lights, we create a potential, let's say, dangerous situation for people going near these counters, these refrigerators. In fact, the exposition of our skin for a long time to these beams can create health problems. So what? It's necessary to stop the emission of these UV lights when a person goes near the refrigerator, near the counter. So we need to detect the presence of a person through the usage of a photoelectric on an ultrasonic sensor. And also in this case, we can base on M18 models with 90 degrees emission, so that we can reduce the installation spaces. And also in this case, when using photoelectric sensors, we can base on the infrared emission, avoiding the so-called viewfinder effect. As I said before, one of the recommendations of the World Health Organization is represented by the not frequent touch of the handles when opening the doors, because they are surfaces touched by everyone, and they can transform themselves in a, let's say, in a great transmission mode of the virus. So what? We can use some automatized system to open the doors. How? By simply using this capacitive sensor installed behind a panel and able to catch the presence of a person who is moving, who is just moving the hand in front of the sensor at a distance of about some millimeters. We have installed for these applications as a solution a CQ50 product, a CQ50 sensor, which is a capacitive sensor of a rectangular shape, of a rectangular housing, which is based on a high compactness, is very flat. So it's possible to install it wherever we want in limited installation places. Now we have seen some of the most significant civil applications, and we can move to the industrial applications. Why? Because this virus can be fought not only externally by managing this new situation with overcrowding of people, with the surfaces, and so on and so forth, but also through the production, through the manufacturing of these PPEs, these personal protective equipments. In other words, we have to grant that the industrial plant producing these objects work in the right conditions, work well. We can see here a plant producing these personal protective equipment where different materials are joined together and where these, let's say, rolling coils are acting. Here, it is necessary to grant a continuous feeding of the plant itself, because every interruption into the feeding process can create serious problems, can be very costly. So how can we continuously monitor the level of this material rolling up on the coil? Through the usage of an ultrasonic sensor that, with the analog output or with the IO-link communication, is able to provide us the right measure of the diameter of the coil itself and provide us the information about the eventual substitution of this rolling material. Of course, we selected this technology, the ultrasonic technology, because of the independence of its way of working from the color of the material, of the target material. Let's skip now to another interesting application we just solved. We are talking about safety issues at work. As you know, we're working with an automatic plant. There are often some moving parts, and these moving parts, if not managed well, if not, let's say, managed in a way that stops the plant when an operator goes next to the plant itself, can create some dangerous situations. In this way, we can install LS2 or LS series. They are lights, curtains, which create a real, let's say, barrier. In other words, they give an impulse, a signal to the machine to stop itself when an operator goes, let's say, over these beams. At last but not least, we can see this further application in plant producing the PPEs during the terminal phase, where we have to stock, to pack and ship these equipments. Here we can observe a conveyor where these products are transported towards the shipment, let's say the shipment department. And we want to detect the passage of each one of them. Here, the irregularity of the shape of these surfaces pushed us to select area sensors that, thanks to their cross-beam let's say emission, are able to detect any kind of objects, no matter the shape of their surfaces. Okay, now we move to the final part of this lecture, where we want to share with you two of the above mentioned applications. In particular, we want to show you how does it work, the hygienic dispenser application, through the usage of a background suppression photoelectric sensor. And on the other side, we want to show you how does it work, the solution of the contactless door opening system through the usage of a CQ50 sensor. Let's see now practically how does it work, a photoelectric sensor with a background suppression model. In particular, we have selected for this practical demonstration sensor of the SS1 series. What are we going to observe now? We are going to observe the ability of this sensor to catch the presence, in this case, of a black glove. So even if you are wearing a black glove, the sensor is able to catch the presence of your hand, let's say below of the automatic dispenser. Now we can observe that the sensor is able to catch the presence of a blue glove, as you can see by the activation of the LED. And finally, you can see the detection of a hand, a simple hand. In this case, we want to underline the ability of the sensor of catching any kind of object, no matter of the color of the surface, at the same distance. In fact, as you know, a photoelectric sensor is highly affected by the color of a target, and overall by dark surfaces. In this case, you have observed that also in case of black gloves, the sensor was able to catch at the same distance the hand as the case of the hand without gloves. Let's see now practically how does it work, our capacitive sensor within the application of the automatized opening doors system. In particular, as you can observe in this picture, we have installed our CQ50 sensor beyond plastic panel. And we have also our tester with the display, which is going to show the activation of our output. Now we can see that simply passing in front of the sensor at a distance of some millimeters, so without touching the panel, the output is activated. So you can imagine, now it's a simulation obviously, but you can imagine that this signal in the reality can activate the opening of a door. Okay, now we just arrived at the end of this webinar, and we can, let's say, summarize what we have learned, what we have discovered today, following the same guidelines we have seen at the beginning. About the temperature control, we have seen the application with thermoscanner. So the installation of ultrasonic sensors allowing the detection of the presence of person just in front of the thermoscanner itself. Second point, we have seen the application of the hygienic dispensers able to grant us to wash our hands when entering a public space. Then we discovered how to manage the overcrowded, let's say, environments by controlling the inflows and the outflows through the installation of retroreflective photoelectric sensors. What about the cleaning of surfaces, the sanitization of surfaces? We have seen the usage of photoelectric and ultrasonic sensors, which detecting the, let's say, the presence of a person near to a counter, near to a refrigerator, give the right signal to stop the emission of ultraviolet lights, which are very dangerous for the human safety, for the human health. And we have seen also for the civil applications let's say, the way of avoiding the touch with handles through the installation of a capacitive sensor of a CQ series, enabling the opening of the door without the touch. Then we discovered something about the, let's say, the manufacturing process of the face masks. And we have observed how the ultrasonic, the safety devices, and the area sensors can be used in order to grant the regularity of these manufacturing plants. Of course, there could be a lot of other stuff, a lot of other things to be said about this topic. And if you are curious or you need more information, please contact us. And I invite you to write at info.microdetectors.com. Also for providing us some feedback about this webinar. And I also invite you to visit our website to discover what's new, what's going on, microdetectors.com. Thank you very much for your time, your attention and your patience, let's say, and see you soon at the next webinar. Bye-bye.
Bye.